Kia ora tātou. Thank you for that. I don't need to do my first slide, I don't think. So thank you again to John this morning to introduce the Manukau Harbour Synthesis Report, which we did in 2021, which brought together all of the information we had on the catchment from our long-term monitoring. We're in the process at the moment of doing the next iteration of regional state of the environment monitoring reporting, which will draw together all the new information over the last 5 years for the Manukau Harbour. So what I'm going to do today is provide an overview of what we have to date, and so for people that haven't read the report, it'll be a bit of a quick once-over of some of that, and I'm also going to highlight some new monitoring and research as well. So just a sort of explainer of what regional monitoring is about. It is about trying to look at the long-term changes that occur in the harbour. So we're trying to achieve regional coverage right across the whole region, to look at representativeness of different habitat types, so harbours, estuaries, forests, dunes, wetlands, as well as the different land use pressures, so rural land, urban and native, trying to achieve a long-term data record so that we can see things changing over time and understand what is driving that change. As a team, we have data that's collected continuously, so feeding in through sensors straight into the office, as well as out there with field teams weekly, monthly and annually, depending on what we're monitoring. And the role of the information we're collecting is to try and provide that evidence into the decisions that are made about our harbours. So this is a snapshot of the Manukau Harbour in terms of the monitoring that is carried out around, from the freshwater through to the marine, the soil, the land, as well as air, and we also do greenhouse gas inventory as well. So quite a lot of dots there you'll see. And as I said, long-term monitoring is really important for understanding change over time, and the Manukau has some of the longest monitoring data, both in Auckland and in New Zealand. So back in the 1960s and 70s, the monitoring was started with the groundwater and the hydrological type monitoring around river flows, and then you'll see marine ecology and the coastal water quality started in 1987, and that was a direct result of that Waitangi Tribunal report from 1985, and that actually set the basis for regional monitoring. So we started in the Manukau, quite intensive monitoring programs at the time, and then they've actually been rolled out across the region. So the Manukau is our longest monitoring data sets for those. And the three there, what I'm going to focus on today is in the harbour. So coastal water quality monitoring, so we monitor this monthly across 35 sites across the region. We've got 12 sites in the Manukau Harbour, which started in 1985. So we've added new sites in 2009 and 2012. The focus of this monitoring is on the ecological water quality monitoring. So bathing, beach and recreational sort of monitoring is carried out under our Safe Swim program, which you can find on the website there. So this is around parameters that are related to the biophysical conditions within the environment, the nutrients and the water clarity, which all have an impact on the ecology that lives within the harbour. So over those 35 years, we have seen a significant improvement, particularly post those wastewater treatment plant upgrades that occurred. However, there's still a number of, while there's some improving trends, there's still some areas of concern in terms of ongoing degraded and lower water quality. The water quality ranges from fair to poor, with the two biggest impacts being the excess nutrients and reduced water clarity from sediment and other things in the water there. The water quality does improve as you move from the inner harbour to the mouth, and we see that across the region in terms of as you move further away from those land-based impacts. The Manukau Harbour does contain more sites that are impacted by nutrients than other harbours in the area, in the region. And the biophysical conditions within the Manukau Harbour, so that's things like salinity and temperature, are very similar to those in the Kaipara Harbour, so another large West Coast harbour makes sense. The water clarity within the harbour is similar to that within both the Kaipara and the Waitemata. So for sediment contaminant monitoring, this started in 1998, and there's 80 sites for this across the region, and we monitor those. Some of them are done every 3 years, and then we have rotational sites that are done every 6 years. So this is less frequent because the contaminants change much more slowly, so we're not monitoring it quite as frequently as the water quality. The main contaminants that we're focused on are copper, lead and zinc, as well as arsenic and mercury. So we're focused on those contaminants associated a lot with the urban areas. We do some less frequent sampling in some of the rural areas for other contaminants. And we do organics less frequently as well because they are changing quite slowly. So we monitor these because human activities, things like our roading, our roof material choices, generate contaminants that can bind and stay within marine sediments. And that build-up of contaminants can have an effect on the organisms that are living within the marine sediment. And so monitoring that provides us a good kind of indicator of how land use is impacting that marine environment. So within the Manukau Harbour, we've got 14 core sites, so those are monitored every 3 years, and then 12 rotational sites as well. We have added 4 new sites, which are near some of those future development areas, so that we can keep an eye on those as development occurs and see the changes if there are any over time. Okay, so overall the level of contamination within the harbour is relatively low. The Mangere Inlet is the real sort of hotspot, and that's because of that historical input of contaminants. Zinc's the most prominent one, which is what we see across the region as well. The sites, similar to other parts of the region, and the upper reaches of those tidal creeks have the higher levels of contaminants, but still low, and that's associated with the mud that's also in those tidal creeks. And currently those new sites next to the urban development areas are at all low contaminant levels. So these were sampled last in 2024, at the end of 2024, so we'll have the new results for those coming out in 2025. What we've found over the time period of the monitoring is that the contaminants have been relatively stable within the harbour, but we've seen improvements over time. Particularly, as I mentioned, the Mangere Inlet is that long history of input to that area. But as that has been improved and we've improved practices and taken away some of those sort of industrial discharges, we've seen an improvement in the state. So this is in the early 2000s. Oops. Okay, and through to the 2021. So you can see that change from sort of red and green, which are our kind of not so good levels, to just about just a couple of amber locations there. And we've seen lead decreasing across the whole region, which follows the removal of lead from petrol. But muddiness continues to be an important factor in those tidal creeks, and that's where the contaminants can build up associated with the mud. Oh, that's the lead declining. I had a little bit of a chuckle this morning with the TikTok videos. I can affirm that you do marine science for love, not for money. And some people study turtles, and some of us study benthic ecology. So another word from this morning, benthic basically means bottom. It's the stuff living on the bottom of the sea, in or on the mud. So not quite turtles, it's kind of the worms and the shellfish, but they do the most important job in the harbour in terms of being a food source and turning over the contaminants, filtering the water, and just being the sort of powerhouse within those vast tidal flats of the Manukau Harbour. So our marine ecology program, it looks at the relationship between the things living in the harbour and the sediment contaminants, the organic content, the chlorophyll, the mud. And we calculate these health scores that are based on both the species present and their numbers. So on the right there you can see an excellent health area, so there's lots of different species in there, lots of shellfish, lots of worms, lots of different types of things living there. In the other core, which is from a more impacted area, we start to lose the shellfish, we might see a few more worms, but less species and less numbers. And we can tell what's driving some of those changes by looking at what's in those cores. So on the left side, we've got the wedge-shell Macamona, that likes more sandy areas, and if you start seeing a transition to crabs are really important, but they do like more mud, so they tend to hang on longer as conditions get muddier. We've learnt a lot from the long-term monitoring within the Manukau Harbour. So this is just looking at cockle populations through time at one site, and you can see there's a really clear cyclic pattern. Every sort of 5 to 7 years we get these increases, and that aligns to those sort of climatic cycles. Understanding that makes it much easier for us to then see if there's anything else going on, rather than trying to pick a point along there and thinking there's something happening when it's a cycle. We're also able to see really clear changes post the wastewater treatment plant upgrades. So this is a worm that likes a lot of mud and it likes nutrients, and saw very dramatic declines when the improvements in water quality began. So within the harbour we've got 2 core sites that are monitored 3 times a year, every year, and then we've got some rotational sites, and we monitor those for 2 years and then we rest them for 5 years. And keeping those 2 sites going continuously allows us to sort of check back in and for those rotational sites. And we calculate these scores based on the number of organisms there and the types. And you'll see there's a full range of health within the harbour, with blue being excellent. It's actually one of our only locations with an excellent score, which is the Auckland Airport location. But right through to poor, same as we see in the other parts of the region, those upper estuarine areas are the ones that are most impacted. Post the treatment, those improvements that we saw with the wastewater treatment plant, we've not seen a lot of strong trends in ecology since then. There's quite a lot of variability. So just some quick conclusions for monitoring. So those decades of monitoring has taught us a lot about the harbour, but also around ecology and its relationship with the environment that we can apply to the rest of the region and the rest of New Zealand. Water quality ranges from fair to poor, and it's impacted by nutrients and water clarity. The sediment contamination is relatively low and it's improving in locations, but we're keeping an eye on those new locations. The central body of the harbour has good ecological health, but again those tidal creeks and upper parts are impacted by mud, and that has an impact on what lives there. So we want to keep continuing this monitoring because it helps us understand what's happened in the past, but also we can keep a track for population growth, land use change and climate change as well. And I just noted there that microplastics and emerging contaminants, they're big issues that are sort of becoming more topical. They're quite hard to monitor in the long term, but we're doing research and working with a whole lot of people to try and understand how we can better track those over time. And then just a couple of really quick sort of new projects. Mention climate change, so your intertidal areas are going to be really susceptible to climate change, not just from sea surface temperatures, but also the air temperatures. So they're getting cooked, by warmer temperatures when the tide's in, and then when the tide goes out, they're getting cooked in the air. So we've got these temperature loggers out to try and understand how that's changing through time and what the difference is between tidal cycles. We're putting those on intertidal reefs as well, and in our wetlands and our forests and associated with seabirds. Marine habitat mapping, really important to understand where some of our most important benthic habitats, so the habitats on the bottom are. This map just shows sort of the level of information available. You can see there's not a lot for the whole region, in terms of it mostly sitting in that green space, but even less for the Manukau and the west coast. So come next month, we'll be out having a hydrographic survey of those deep channel areas, which will give us a huge body of information to understand the sea floor and the diversity that may be there and add to that story. And we've got some seabird monitoring happening along the Waitakere Ranges, but also within the harbour, monitoring shags to understand where their roosting and nesting areas are. And just if you're looking for information, things I've talked about today, we have an environment portal where you can either access some of the live information or request data. And in the next couple of weeks, we'll be making available a water quality and river ecology data explorer, so you can actually get in and play with the data and look at different sites of interest. Reports are all available on Knowledge Auckland. You can email us questions anytime and we'll try and help. And also noting that Land, Air, Water Aotearoa is a site where all regional councils place their monitoring information, so you can look at Auckland in comparison to the rest of New Zealand. I'm going to pass to George.